right. Hello, everybody, and welcome to today's webinar. We are talking about a pretty cool topic. We're going to be going into how to use third-party materials on XiP, which is our professional desktop 3D printer. And I am joined by Taylor Hardy. Taylor, what's up?
Hello, everyone. Hey,
Taylor.
Sean.
Hey, how's it going?
Fantastic.
Good, feeling good. Anyway, so I'm Sean. I'm the head of content at Nexa3D. You may have seen me if you've seen one of these before. Taylor is a sales engineer and man of many talents over at ELP3D, which is one of our fantastic resellers. He's also the creator of the XiP user community on LinkedIn. So if you want to head over, join that, talk XiP there, you definitely recommend that. But yeah, like I said, today we're going to be talking about third-party materials. Taylor has a bunch of experience doing this, maybe more experience than anyone I've seen do it. So he's the perfect person to ask questions about during this. So if you do have questions, please drop them into our chat or the Q&A tab, and we'll try to get to those throughout. My first question for everybody is, where are you from? Let us know where you're watching this from. I always like to start out from that. I'm out in Portland, Oregon. Taylor, where are you at today?
I'm located in Toledo, Ohio, so the Rust Belt.
Heck yeah, cool. I'm gonna ask you if I would ask you if you're Ohio State or Michigan leaning, but I don't want to get into politics here.
Oh, I'm just a Browns fan, so
me too.
it's a rough life as a Browns fan.
Exactly. Cool. Well, before I go down the rabbit hole of football talk, let's get back on track here and tell you a little bit about Nexa3D. If you're not familiar with us, we are the manufacturers of 3D printers, and our goal is to build a sustainable digital supply chain through additive manufacturing. And basically what that means is bringing localized automated manufacturing opportunities to local areas or to actual OEMs so that they can easily manufacture their own parts, create customizable solutions, or create a digital supply chain in which inventory is actually kept on your computer, on your server, and then you just print parts as needed rather than having a big stockpile of spares in a warehouse, right? So it's kind of our goal. And we manufacture these ultra fast 3D printers that I'm going to talk about in just a sec. All of our products are designed and manufactured right here in the US, specifically in Ventura, California. And our printers are used by a diverse group of customers with a common need for speed. So again, our whole thing is ultra fast 3D printing, some of the fastest 3D printers you will find on the market today. And yeah, you can see a couple of our customers there, but a real diverse set of industries, from consumer products to service bureaus to government agencies, racing, Formula One racing teams, furniture manufacturers, sporting goods, lots of others, but didn't want to put them all on here. So that is kind of a little bit about who Nexa3D is, and I'm going to launch a quick poll and let people tell us who they are. So if you could take a second, click your answer. Which best describes you? You are 1, I'm interested in getting my first 3D printer. 2, I already have a 3D printer, but I could use an upgrade or an addition. That's definitely me. 3, I already have all the 3D printers I need. Or 4, I'm just curious about 3D printing tech, but don't have a specific application for it right now. So we're going to give you about 5 more seconds to answer that question. 5, 4, 3, 2, 1. I'm going to throw the results up on screen here. Okay, so looks like most of you, as usual, already have a 3D printer of some sort, but could use an upgrade or an addition. Looks like a decent amount of you actually have a lot of printers already. So cool, good, pretty should be a pretty knowledgeable 3D printing crowd here, Taylor, that we've got on hand. But you know, that's not too surprising with the topic. All right, so I'm going to turn it over to Taylor and let you tell us about Elk 3D.
Yeah, so at Elk 3D, our mission is to be the go-to provider for cutting-edge, innovative 3D printing solutions. So, whether it's a big or a small company, we're interested in help bringing new technology to the market. So, help increase volume. Nexa3D is the only SLA printing company that we work with. We work with a few others, but I'm not going to mention them right now. And we're a third and fourth generation family business owners. We have my personal family had a business in Cleveland doing marine diesel machining, and that dates back almost 75 years. So it's a family owned and run company, and it's all privately held. We're all focused on manufacturing, reshoring, distribution, and white glove gold star service, just like Nexa.
Awesome. Yeah, we love Elk 3D, and we love working with you guys and doing webinars like this with you too. So all right, so what are we talking about today? You already know what the topic is because you joined the webinar for that. But here's the agenda. We're going to start out. I'm going to give a quick intro to the XiP platform for those who haven't seen that. Maybe some of you already have XiP, but be curious to know that for sure. Two, we're going to talk about why you would want to use open materials. We're going to talk about how to use XiP open mode. We're also going to go into choosing a resin to get started with, or how Taylor kind of picks his resins. And then we're going to talk about some real world applications of the XiP open platform. And yeah, it looks like Marcus actually does have his XiP up and running in the shop. Glad to have you on here, Marcus. Hope it's going well. Yeah, it looks like people from all over the world too. Before I forget, we've got Austria represented, or maybe you're currently in Switzerland, Mario. We got Montreal, Canada, Ventura, California. Nice try, Tyler. He works for Nexa. We've got Texas. We got Colorado, Olympia, Washington, Stuttgart, Germany. Very nice. Cool. Well, I welcome everybody. And yeah, like I said, don't forget to drop questions in that you have if you think of them throughout, and we'll try to get to as many as we can by the end. So shall we get started, Taylor?
Absolutely.
All right, let's go. All right, so I'm going to give you guys a quick intro to the XiP 3D printing platform. So the printer on the left there is the NXE400 Pro. That is our industrial, Nexa3D's industrial offering when it comes to resin 3D printers. It is an ultra fast industrial high throughput resin 3D printer. You see these at, particularly at big companies or service providers who need a lot of throughput or very large parts. These printers are not necessarily cheap, although I would say they're extremely affordable compared to their nearest competitors, which I'm not going to name by name, but other very high speed industrial resin 3D printers. Anyway, so those have been around for a few years now, and they use something called LSPC technology, which is a proprietary technology invented by some of the founders of Nexa3D. And this year we came out with the printer on the right that you see, and that is XiP. So XiP is the world's first ultra fast desktop 3D printer for professionals. And it basically has inherited all of that industrial technology. It's actually incredibly rare in this industry to see a desktop 3D printer come out of a company that started out with industrial printers and has brought that kind of patented technology. It's really cool because it's making it accessible for a whole, a ton more engineers who can now afford this technology and to get started with this high-speed 3D printing. So let me tell you a little bit about how it works and first off, how it compares to SLA 3D printing. So this is actually not SLA 3D printing. This is MSLA 3D printing, which is what I like to call the third generation resin. Okay, so SLA is the OG, invented back in like 1980 or something by Chuck Hall. It works with basically by shooting a laser, projecting a laser, reflecting a laser off a mirror, and that laser beam basically draws out the entire layer. You guys probably know this already because a lot of people have 3D printers here, so that's great. On the right side, you've got MSLA, and that's what Nexa3D uses. So instead of using a laser to draw out the entire layer, where basically, if you think of like a 4K TV, that's basically what you've got here. It's an LED-backed LCD masked screen. The LED lights are UV lights. They're of the UV spectrum. So they're projecting up through these collimating lenses here. So you get very crisp light that's projected up. It goes through the LCD mask, which is going to allow you, it to project the image essentially. And then whatever light is coming through is going to create that entire layer. And the benefit of this is you get to project the entire layer at once. So you can, with certain materials, you can print an entire layer in about 2 seconds, which is really cool. SLA considerably slower than that because it's got to draw out the entire part. So the more spread you have on that layer, the longer it's going to take for that. With MSLA, that's not the case. It doesn't matter how much you put on that layer, it's going to take about the same time. So a really big benefit right off the bat with just MSLA 3D printing. And that's not even our proprietary technology. That is just a technology that exists. However, the Nexa3D, of course, I mentioned the proprietary tech. We do it a little bit differently. So we have something called LSPC. It uses these membranes here to allow the layers to basically, every time you print a layer, it's got to lift off the bottom, right? Because it's kind of hanging down from the build plate, and then you've got the plate, and it's kind of printing on the bottom. When you lift those layers up, there's a tremendous amount of force that, especially if you have a really big part or lots of parts, right? And so what this membrane does is allows that force to be dramatically reduced, so we can print a lot faster. We can pull the parts off faster. We can print bigger parts, more complex geometries with fewer supports. So that is kind of one of the main benefits to the Nexa3D technology, and kind of what makes it such a, an even higher throughput, even faster technology than is available otherwise. And what does that mean in terms of speed? Well, with XiP, you could build one unit in about the same time, with one unit to build the same amount of stuff. You would need about 2 to 3 printers on a DLP or MSLA competitor, or 5 to 7 print units. When I say units, I mean printers. You would need about 5 to 7 printers to match that throughput. Some of the most popular resin 3D printers out there right now are SLA, and that is not a typo. You could basically replace 5 SLA printers with one XiP. It is that fast. So, just something to think about. But like I said, we're all about ultra fast 3D printing, and that's no joke. We also have XiP also has a wide array of validated materials, both modeling and engineering grade materials. So obviously that's not really the topic here. We're here to talk about third-party resins, but obviously with XiP you can do both. So if you have third-party resins you like, you can use those. If you want to try some of our validated materials, that have been really tested and dialed in, you can do that too. And we've got, some examples of the materials we have. We've got flexible materials, we've got ABS analogs, we've got PEEK analogs, PP analogs, whole variety of modeling materials, dental materials, stuff like that. So, and how does the material work in ZiP? So we use a smart, sustainable, self-filling cartridge system. This cartridge is actually made out of aluminum. So when I say sustainable, it's a more recyclable than you would typically find in resin bottles. When I say smart, it does have a RFID chip so that when you plug it in, the printer knows what kind of resin is loaded, and kind of gives that feedback loop to the whole platform. And self-filling, so it actually drops directly into this little part of the resin vat, and it's got a little valve on it, so it's just going to keep, as long as a new bottle's full, it's going to keep that full level of resin in there. It's going to keep filling as you're printing, so you're less likely to run out in the middle of a print. So some very, very nice user experience benefits there too. You'll notice it plugs right into the vat too, so there's not like a whole loop of messy like resin in like tubes or something within the printer. You don't have to clean out some kind of internal system. So that's all I'm going to talk about with ZiP, but if you want to learn more, you can go to nexa3d.com/zip and check it out. And with that, we're going to start talking about open materials, what we came here to talk about in the first place. So I'm going to pass it over to you, Taylor. And why don't you take us through why someone would want to use open materials on ZiP?
So why would we want to use them? Most obvious reason is, most of the people in the beginning that answered the poll already have a printer. So you can use all the existing supplies of resins, that are available. That's one of the biggest reasons why having an open platform is so important, because you can use up your current inventory. So.
Cool. Yeah. And
so
yeah.
Also, you may need some specific properties. One of the benefits of being able to run open source is, currently there's a limited amount of flexible validated resins. So you can actually find other, sources of those flexible resins, either directly from Henkel or directly from BASF. And you kind of know with certainty what is going to give you a good print quality. So, but on the open source side, you can read a lot of reviews. There's a lot of technical data out there that kind of lets you do quite a bit of things. And it honestly just lets you be really creative and solve a lot of problems that you might feel like you might have. But this makes it a lot easier to get into the nitty gritty and, get jobs done quickly. So another advantage is you can do different color mixing and dyeing. That was kind of one of the big responses I got from one of the posts. I think it was on the first slide. I was mixing colors to make a green color for just something I'm doing around the house, but we've had to mix dyes for different clients because they're trying to achieve a specific end product with the printers. So you get a lot more flexibility having an open platform. You can actually buy specific dyes. I think even with the X-Flex, there's a dyeing kit with that. And people have taken the time to write out specific instructions on how to do that correctly and achieve good results with it. And also, the cost. Sometimes there's clients that are looking to bring new things to to the market, and they just really need to see it in the physical realm. So when it comes to prototyping, being able to use open materials, it can cut the timeline down a lot faster. whether that's something you already have and it's something that you already know the image quality or, you know, what the quality is going to be like when you print it. You can use that open source until you're ready to go something that's more validated or just specific use case, you know, trying to lower costs overall to increase overall net profit. And of course, flexibility, you know, having an open source platform, you can just choose to use whatever materials you want. I mean, I've noticed some of the open source materials are also listed as additives. So if you really wanted to get creative, you could mix certain things together to get somewhat of a semi-hard flexible, or you can mix flexible resins together. Some are listed as additives. So you know, besides what there is available to the validated resins, you have a whole nother market side that you can, that's at your disposal.
Awesome. Yeah. Now I would just add, like, the flexibility of the ZiP platform of being able to use open and Nexa validated materials kind of gives you the best of both worlds. You know, even a step farther. So you basically have infinite possibilities of materials you could be using, and then you can always, you know, if you really just need something that you know is going to work without spending too much time like experimenting, you can go back to that as well. So cool. So that is kind of the why. Let's go through, take us through your process for choosing resin to get started, or I guess for the next project.
I mean, choosing resin is, you know, really, it's really depending on the application that you're using, whatever you're designing, prototyping, you know, putting to market, you know, whether or not you're having to piece something together in multiple parts, and, you know, you need to find out the tolerances and what the actually industry and what kind of specific application you need. You know, sometimes you need to have a specific shore hardness or tensile strength, or, you know, I could go on and on, but you know, there's a lot of good information that are on the online retailers. There are, of course, specialty premium resin websites. A lot of the resins I've been getting is stuff that you could just find on Amazon, because a lot of the stuff is that I'm printing in my off time is just stuff around the house to make it look nice. Printed a few things for my kid to try to get him more interested in this technology. He's only 3 right now, so it's very limited, you know, what you can do. But you know, the point is it having access to being able to see all the results as well as people's reviews. It kind of helps narrow down how to choose the resin properly. So a lot of, you know, you're going to have to pick some type of property, whether it's ABS or I've even seen some nylon type resins available on the open market. You know, in the reviews, it's going to kind of tell you specifically what kind of quality you should expect out of the resin, but also a lot of times people take the time to go through and give you specific parameters in which you would want to run the printer at, you know, regarding exposure time, base layers, but also the manufacturers have uploaded that a lot to the profiles that are on these open source pages. So of course you want to make sure you're picking the right type of resin. You know, some are listed strictly as DLP, some are more for LCD, SLA, some are both. And then of course you also see some that are specifically advertised for MSLA, which is, that's kind of what I prefer to go with, something that is going to 100% work with the machine that I'm using. So of course you always want to be cognizant of what resin you're buying, because there are a lot of options out there. Of course, if you're using the ZiP or the NXE400, you want to use something in the 405 nanometer wavelength. All that information is always available within the product descriptions. I don't think I've ever seen an instance where it's not. So, and of course, just read the reviews. Like I stated before, there's a lot of good people that are using things professionally on the open source side that have taken the time to review things and actually give their opinions. So a lot of times there's pictures of, so you can see what kind of print quality that you're actually looking for. So yeah, of course, I think I mentioned this before, there's always going to be printing recommendations. You want to make sure you're not near a window. You want to make sure, you're storing your resins correctly at the right temperature. You always want to give it a good shake before you load it into the platform, and make sure you're using proper PPE. So it's pretty standard for anybody that's used an MSLA printer before, anybody that's printed with resin in general.
All right, cool. I mean, that seems pretty logical to me. I think probably everybody on this call has used Amazon before, so I think that's. I think one other bonus you mentioned to me is, well, what everybody loves about Amazon is 2-day shipping too.
Yeah, I mean, some stuff can show up literally if I order it that
Yeah.
afternoon, it's been showing up in the next morning. So it
Yeah,
helps just increase the workflow. I really just like to run my machine 24 hours a day. Doesn't matter what I'm printing, whether it's for a job or something around the house. So
right. Cool. Well, with that, let's talk about a couple real world applications of a zip open platform, where you've kind of seen open material, or where you've kind of used open materials.
now, yeah, I mean, on the professional side, right there on the screen, those are samples that I made for orthotics, people that do medical devices for people, trying to open up the idea that, this is more, and I actually have it right here. This is, for the medical use, it's a better option. It reduces infection. I actually had a student reach out to me saying this is what her thesis is on, is 3D printed casts and the ability for it, because they're waterproof, it reduces infection, it's breathable, and it's just generally more comfortable because it's like 1/8 of the weight of a plaster cast. So there's a lot of uses for 3D printing. Some people are embracing it full speed and doing stuff exactly like this. And then there's some people that wanted to do it the traditional way, which, is fine. So but one of the other examples that we were able to come up with for a client of ours is we were able to come up with a tool head cover that protected the light on an assembly line so that the light didn't keep getting broken off. And we use a flex material. It's actually this one right here, which this is a hose fitting. I had some extra, and this is one of the open source flexibles, but it's one of the more professional ones, the ones that actually have been used in a professional setting before. So I don't know if you guys can see the image quality of that. It's, some people ask me if it was injected molded. So
Cool.
yeah, actually I have one of the orthotics for a client. This is something I've shared on LinkedIn. You can see right there in the picture, that's just a perforated version. But again, when it comes down to end product uses, you can actually get really, really great results. And this is actually with one of the validated resins, because that's what's required. So I brought some other things that I've been printing. I was trying to test the overall volume that the ZiP can achieve. This is a guitar bass that I'm doing. Oh, I'm sorry, I have that backwards. A guitar bass that I'm doing to donate to a local music program. So with the open source platform and a machine like the ZiP, your options are literally unlimited. You can do so many different things. This is something my wife asked me to print. This is the painted version of that. So I don't know if you guys can see that.
Very cool.
So, and this is actually a dinosaur skull I did for my son, just again, so get him into this kind of technology.
Totally, that's awesome. All right, yeah, let's go to the next one. This is actually one that I added. It's not one that Taylor did, but it's definitely something that we've talked a lot about. It's kind of a little different because, you know, Nexa does these partnerships where we have worked with companies to develop you know, their kind of third-party resin, like their resin, and make it like a proper solution that's kind of integrated into our platform. And that's what we did with AdiFab. So this is kind of a cheat example, probably not what everybody is how everybody's gonna be using third-party. But if you haven't seen, you probably have seen this if you follow us, because promoted it quite a bit. But Wilson, in this case, the sporting goods company, uses the AdiFab resin to print molds for their injection mold machines, and then they can mold the bat handles, this black part on the left side, with those molds. And you know, it's a whole new way to do tooling. So I think it's kind of a cool example of, you know, maybe a bigger partnership, a bigger kind of solution, if you will, for an industry like the tooling industry that's, you know, been around forever. Usually those molds are machined, and in this case you can print them, you know, kind of, and the molds can withstand, you know, very high heat, very high pressure situations where you're injection molding, you know, composite like materials or whatever materials you want. So the mold itself is kind of a third-party material, and then obviously the injected material is also a third-party material, not a printed material, but just kind of a cool example. And actually, we're doing a webinar, quick plug there, in about 2 weeks with. It's actually gonna, I think it's featured on additivemanufacturing.com or something, but where Wilson and our very own Lewis will be talking about that project. So check that out. Maybe I'll drop the link in at the end of this. Okay, so how do you use Zip Open Mode? How's it all work? So I know they're obviously, being kind of an open platform, there are a few different ways to do it. I won't say this is the only way, but this is kind of the prescribed way that probably is going to be the best user experience for most people, especially if you're using like this regularly, systematically, you know, for business applications. Maybe, you know, a couple resins that you're going to use a lot of. This is probably the best way to do it. So first things first, Nexa X is our software. It's our slicer, if you will, and their Zip inherently comes with a free version of this called Nexa X Basic, but we also have a Pro version. And so some of the things you get with Pro are, you can get additional custom settings that you don't have with the basic. So I don't know, now I wish I kind of would have screenshotted it. I think you'll see it in the next video. You also have the ability to auto repair, corrupt models. So it's got some analytics and part repair kind of tools built in. There's an edit feature as well, which allows you to hollow out, you know, very thick parts if you don't want to use all your resin printing a solid part, because that is actually kind of the default, which is something that's kind of new to me, coming from the FDM world, where the default is 10% infill. And ironically, it's still like 20 times slower than this process. But if you actually went solid to solid, like an apples to apples comparison, it would be like 100 times slower. So rarely do you print solid in FDM, but that is actually the default with resin, as some of you know who already use resin. So anyway, you can hollow this out, you can generate internal structures, kind of mimicking that infill of FDM, if you will. And then you can add like stuff like a perforation to allow for drain holes. And of course, what we're talking about here, custom resin profiles and the ability to save settings for multiple profiles of the same resin. So again, if you have your kind of go-to materials that you want to be using, or even multiple settings for those materials, you can do that too. So I'm going to play a quick video to show what that looks like in Nexa3D XiP. So check it out. Okay. Can you hear that?
Click on the custom settings button. You will need a Nexa3D Pro for zip license to open this menu. Next to the resin drop-down, there's a gear icon. Click it to open up your custom profile library. Uncollapse the printer menu to see the available resins. Click the plus button next to zip to add a custom resin. Once you've named it, hit save. It should then show up in your list of resins. To remove a custom resin, check the box that appears next to its name and click the remove button. You can also bulk remove any custom resins by clicking on the checkbox that appears next to the printer name. But I don't want to remove it right now, so I'm going to go ahead and uncheck that and close this dialog box by hitting the X. And now you'll see my cool resin shows up in my resin drop-down menu. To create a custom setting profile for your custom resin, hit the plus button next to the profile drop-down, save an appropriate name, then you can change your parameters. In this case, I'm going to bump up the exposure time on the base. Hit apply to save your changes. And now you can see I have my cool new resin and my profile for more exposure. Please reach out with any questions, and happy printing, everyone. Nexa3D support here. Today we're going to talk about
God, Google Slides is the worst at leaving a video. That was the voice of our very own Shay, who was on the Zip support team. So shout out to Shay. But yeah, that just gives you kind of an idea of what those custom settings look like and how you create those custom profiles in Nexa3D. So that's kind of that's the first part of the solution or zip open mode, as sometimes we call it. Second part is this custom resin cartridge. So I mentioned at the top of the presentation that we have these aluminum material resin cartridges, and they have RFID equipped and some like nice usability features like the auto fill, or the fill as needed for the vat. So the thing with this is, like, I would say if you're I think Taylor, you probably have done this too. You can also pour resin straight from the bottle into the vat. So I think, like, the first time you're using it, when you're kind of mixing, matching, experimenting, trying a new resin for the first time, I wouldn't say it's absolutely necessary to start with this cartridge. When I think it's probably most beneficial is when you've kind of locked in, like maybe that print mode dialed in, you're going to be using this resin for this application over and over and over again. Probably worth it to get one of these bottles. Then you can pour the resin into there, you can refill it as needed, and it's gonna hold a kilogram of resin for you. And yeah, you can just plug it straight into Zip, and that chip will program with your custom print mode too, so it'll all be in sync with the system. It'll auto fill as you're printing, so you'll get all those benefits too. So that's just kind of an add-on as part of that Zip open mode that you can get as well. So those are kind of the two main things. Other than that, Zip's it's just a fast, versatile platform in general. It's a solid platform, I would say. We didn't talk a lot about like things like the build quality that are, I think, a huge benefit of Zip. I don't know, Taylor, if you what your experience has been like with that build quality, or if that surprised you at all. I know when I first interacted with a zip and opened the door, I felt like I was opening a vault. The thing is built like a tank.
Yeah, I mean, I'm a big fan of anything well engineered, and that's kind of why I run it 24/7, because I'm not trying to break it, but I want to see exactly, where the limitations are, and I really haven't found much as far as somebody could be breaking it easily. I mean, if you worked around printers before, you're going to be pleasantly surprised, even if you've had, like, I had a couple issues with a membrane, and that was my fault because I was learning on this printer. I mean, I did training on the NXE 400 prior to getting this printer, but having one using it full time like this was my first SLA printer. But again, going back to having a spill, which it's going to happen at some point during ownership of a printer, that you're going to have resin on the screen. I was able to get it off safely. Everything still looks brand new. So, props to the people that put into the time to design this machine, because like you said, it's incredibly well built. It's like a tank. So
Yeah, totally. Yeah, I think so. Yeah, I mean, we talked a lot about zip. Obviously, we talked about what is zip. We talked about using open or third-party materials, what to look for, or why do you use them, what to look for in them, and then some examples of applications that Taylor has seen and used. And then we talked a little bit about open mode and how that works. So yeah, I would just say we're gonna probably jump in now to some Q&A, and if you haven't, it looks like we already have a bunch of questions to get to. Shout out to Mike Curry, who is off camera now, but also answering some of these questions. I might re-answer some just if in case people didn't see those answers, if they're relevant to more people. So yes, apologies if we double dip a little bit, but yeah, get your questions in now as well. Actually, I have a question for you, Taylor, before I start answering other people, and I can do that because I'm the host.
Sure, go ahead.
I'm going to jump the line here. Like in your experience as somebody who's used this a lot, is like, how difficult is it to use some of these resins? Have you found that they generally work as you would have expected, like the first time? Do you have to do any tweaking of setting? Like, do you have to do a lot of tweaking of settings?
So to answer the first part of your question, it's incredibly easy. I mean, I have the Nexa Pro software, so using it, I've used other slicing software before. It's incredibly simple. It's got a very elegant layout. I mean, it's not hard to navigate, and it's not overwhelming, which that's sometimes a problem with some software. I mean, other slicing software, you see a very small menu and it's really hard to read. So the Nexa Pro software, in my opinion, is pretty well put together, and it gets the job done. And whether you're a new user to SLA, or you're somebody that has been doing it for years, it's relatively easy to migrate onto that platform.
Cool. Might have to
as far as your other parts of the question, no, the old adage, you get what you pay for, 100% applies to resins. I've ordered some of the white, cheap ABS like resins, and I'm not going to name names, but almost right after curing, they started yellowing and cracking in some areas. But I've done work with a lot of the validated materials, and they don't do that. So of course, there's a word of caution when you're using something. It depends on the application. It depends on the industry and how specific you need to get. But you know, obviously everybody's in the position because they're in today because they make good choices. So, you know, choose wisely is my advice.
Good advice. Good advice. Let's see. One that was asked about zip. Actually, Mike might have answered this already, but I'm going to just reiterate. So do the pixel contour of the LCD mask affect the quality of the printed part? What's the resolution of the LCD mask? So this is a common question. I would say almost common myth that SLA has like much better print quality than MSLA. I actually haven't used other MSLA printers before, but I have seen like parts by comparison. I know with the zip, you get not just, you get about a 52 micron pixel size, but then we have anti-aliasing technology built into that. So you get what Mike likes to refer to as sub-pixel resolution, where you can basically turn it down to like a quarter of a pixel. That's all automated on the back end, so it creates smoother surfaces, finer feature detail, stuff like that. So personally, I haven't noticed any pixelation. I don't know if you've seen that, Taylor, in your parts, but I mean, again, I've kind of stuck to the validated resins, and they look pretty good to me. So
Yeah, I mean, really, you know, again, it comes back to the quality of the resin you're using. Because some stuff will print great and then it'll fall apart quickly. You know, I had that with one of the flexibles. You know, it's probably not meant to be played, or you know, it's more meant to be played with as a hobbyist resin versus being put into any type of application. So I mean, you know, it's you gotta take what material quality you're putting into the machine into consideration, of course.
for sure.
So I think we have a few other questions.
Yeah. Oh yeah, we got plenty. Armand, yeah, what's up, man? I like your Instagram or your TikTok posts. Guy's a machine. He says, what softwares do you use to add topology, patterns, generative design to your parts? I guess he's talking about like the cast maybe, or some of those.
I'm sorry, could you repeat the question?
Yeah, he was asking if you've created, like, did you create those topology patterns in your part, those complex parts, like the guitar you showed?
No, a lot of those things I found STL files online. I haven't had much time in between printing for clients to do much design in CAD, but I can go back and look and then, you know, give that person specifically who they use, because
Yeah,
it's all listed online. I mean, it's all free files that I'm just more or less, you know, giving out as a sample to show quality of printing. I mean, this was done with PP 405, and that was the first material that I used because I got it with my zip. So you can order materials with your zip to you know, try the validated resins as well. So.
cool. Yeah, I know in my experience, I mean, obviously N topology is like a big name in terms of generative design, topology. I think Fusion 360 has some capability built in. I know I've seen them run those kind of simulations, and those are, you know, those could be hit or miss too. You know, it gives you like, it can give you like 50 options to choose from, and it's all like AI generated, which is pretty cool. You know, you kind of put in your loads, but those are kind of the two that I'm personally familiar with. All right, so let's see. Let's see, has anyone tried using Formlabs resins on the Nexa printer, or does anyone know if they can print on like the zip? I have not, Taylor. I don't know if you have.
No, I have not.
I would imagine there are a lot of people wondering that who have Formlabs printers and Formlabs resins. So I'm personally curious about that too. I'll see if I can get an answer while while we're talking here. Let's see. So
I did see somebody answered in the chat that it's not the right wavelength, it's
okay.
not going to work, which is correct.
Yeah, gotcha. Yeah. So yeah, you just gotta, it's gotta be 405 nanometer for the zip. Let's see.
I see I'm probably going to butcher this. Emma Line asks in the chat, are there any limitations on resin viscosity? Now I can tell you right now, I've used probably really thick resin before. Of course you got to have the right ambient temperature, but that's kind of like this resin is really incredibly thick. It's not entirely different, hard to clean up or anything. However, you don't really have a lot of limitations when it comes to the viscosity of the resin. I mean, have you found any limitations, Sean?
I think probably more on like the feed systems than anything, so if you're using a really viscous material, like the auto feed that valve might not be able to deal with that. So a direct bore would be probably necessary. I know like we don't have a heater built in per se for zip, but if you've used it, first off, there's this heavy duty machined vat frame, and Taylor kind of talked about this before, you put the membrane on that, there's 4 clips and you clip it in tight, and then that creates your vat. That is actually it uses electromagnets to seat like perfectly into place, and it locks in, and like to actually take it out, you actually have to go onto the touch screen and disengage the electromagnets, and so you can take it out. That actually kind of heats the vat. I don't know if that was actually an intended consequence or not, but you do get some vat heating there, and I know that sometimes that is actually necessary for those more viscous resins. So don't know if that answered the question, but it's going to be a bit of trial and error.
Well, and just so everybody knows, on the other end, things that you buy open source that are incredibly high viscosity, you got to be aware that you're using the correct profile. So that's going to require a little bit of testing, or otherwise, I mean, obviously you want to pick the right orientation, but you got to also make sure you got the right supports, and you're not going to get any kind of warping issue when you go to print. So it's really somewhat easy. It's just you got to use a little bit of caution.
For sure. Looks like Mike hopped in and did answer the Formlabs question. So update there. They do use 405 nanometer. So it's the same. So for all you Formlabs users out there who are giving zip a look, and you have bottles and bottles of the Formlabs stuff, you're in luck. You are free to upgrade to zip. But yeah, that's good to know. All right, I think, let's see, somebody else had a pretty interesting question, and it speaks to me because I was also an FDM user before being at Nexa, longtime FDM user and new to SLA and MSLA 3D printers. Typically when speed and performance is increased on anything, printers, cars, appliances, there's generally a caveat. Does speed equal lower print quality and more post-processing, or are there frequent expensive consumables? So let's see. So I guess first off, I'll answer that with the speeds that I use, and like the speeds that we kind of publish are not just like custom tuned speeds. So when we talk about zip as an ultra fast 3D printer, those are like the default speeds. So with this kind of, this is our X45 natural. I don't know if you guys can see that pretty detailed part. This is our X-Rook sample. So if you want to get a sample, you can order one of those. This is our fastest resin, and you could print an entire build volume of these using default settings for the X45 resin, and you could, like, the entire build volume of zip, which is not insignificant. It's significantly bigger than what you're probably used to if you've used SLA or other resin-based desktop 3D printers, you can print about an entire build volume of those in about an hour. So it's incredibly fast, and that is default. Of course, that it does kind of depend on the resin too. So that is our fastest resin. If you're using something, this is printed in our XABS resin. This is a much slower printing resin. So I guess the trade-off there is with the X45 natural, looks really good for kind of modeling and prototyping. Not going to be super durable. So, you know, whereas this XABS, it's a really good analog of ABS, so it's going to be more durable. And I would say that's typically the trade-off I've seen, at least, is maybe the more engineering grade materials with some of those properties tend to print a little bit slower and need a little bit longer of a cure time with each layer versus like faster draft modeling resins. And that's even true with other printers too. It just so happens that XiP is just, you know, faster, you know, draft to draft or engineering to engineering material. So that's a long story long there. I can't speak to the third parties, but I don't know, like speed wise, Taylor, what you've seen there.
I mean, the speed wise with some of the flexibles, just like the X-Flex, it's going to take less time, you know. So I don't have the sample that I hand out, the little knurling bowl.
Yeah,
Like that was a nylon type resin. That's what, you know, it was I don't want to name the name, but one of the more premium resins, and it took like less than an hour. So, and it was about the same height as the Rook, but you know, every time I show that to people at expos or whenever I'm out and about doing any kind of sales calls, people are blown away with the quality because they looked into SLA maybe years ago, and they haven't realized the explosion in material science, but also, you know, the abilities of what you can do in-house, which that's a popular term everybody's talking about these days, is reshoring, you know, lowering the costs of operations in general. So, you know, that's one of the reasons why I created that user community, so people can share information and kind of strengthen their operations within, you know, for people that are using the machines on a regular basis.
right. All right, we're running out of time here fast. Geez, we have some more questions. Is the print time constant per millimeter Z or for a given resin, or is it geometry dependent? It's definitely a little geometry dependent, but yeah. So I mean, I would say it's close to uniform, but I would say like if you do something really solid throughout, there are even like settings, like not even with the custom settings, but just there's like a checkbox for like better solid parts. That's going to add print time, you know, because you want to make sure this like dense part, it may need extra light, right? So yeah, I'm just going to say it's kind of going to be dependent a little bit, but you know, I guess I should say, like, back to that MSLA point where you can like you could print one of these X-Rooks. I will say for a fact that you could print one of these X-Rooks, or you can print 12 of them in the same exact amount of time on a ZiP build plate. So I don't know if that's a good example, but that is the truth. We do live demos all the time on these webinars, and that we have done that exact thing. We printed, well, you know, 12 of these on a build plate, and I think it took like 22 minutes or something. So, you know, the per part time is pretty low. Is it user repairable, friendly? Yeah, it's definitely more. We tried to make it more user repairable. So we sell, you know, we have replacement membranes, which is like a wearable item. We have replacement LCD panels. You can get VATs, you can get build plates. So all those things are pretty easy to change out. with minimal to no tools, depending on which one it is. Yeah, like, yeah, it's like two screws for like an LCD panel, basically. So yeah, and that's probably the most intense change that you could do. The other ones are all like clips and or like slide in or something. So definitely try to make it user repairable. All right, last question. I know we're already out of time here. Let's see. Does ZiP have materialize Magix integration, and what features are supported within Magix? That maybe I should have picked a different question. That's a good question. I mean, I mentioned some of the pro features that it has built in. But I do think we have some sort of integration. I know a lot of people on our team use Magix, especially if they have some really complex, large stacked parts, even though you can stack parts in Nexa by default, but Magix is definitely a popular one at Nexa3D. All right, let me do one more because I didn't really have an answer for that. Taylor, how good is the repeatability in failed prints that worked before on the same resin?
So, I mean, the repeatability is pretty much standard, especially if you kind of have an idea of where you're going with, you know, a specific type of resin. So, I mean, sometimes you will get a failed print, you know, due to orientation, or you're unaware of what profile settings you should be running. So depending on how much information you actually get right off the bat about what resin you're using is going to really determine the success of your prints.
All right. Well, good answer to that. We're a couple minutes over, so appreciate everybody for sticking around and really for joining us. You saw on the screen all the info for Elk3D, so check out their website. You can talk to Taylor and the rest of the team at Elk3D and get a consultation, or join their ZiP user community on LinkedIn. And we also have a promo going on. Elk3D, I think, is offering this as well. So 60-day guarantee on ZiP. So if you want to try it, you know, really got a pretty good deal here. If you don't like it, I think you're gonna like it. But if you really don't like it, you can send it back and get your money completely back. So definitely never been a better time to try ZiP. And yeah, that's all we've got for today. I want to thank Taylor for joining us, being our special guest today. Thank you, Taylor.
Thanks, Sean. Thanks, Nexa.
Awesome. And
thanks, Mike.
Yeah, thanks, Mike, behind the scenes there. Thanks to the audience and everybody who joined. And until we see you next time, happy printing.